Hi everyone, I hope you are okay. Now, in this lesson, we will go on where we stayed there. As you remember, in the last lesson, we had been talking about linear combination of normal distribution, and we had stated an example. Now we will go on work on these example. Okay, now we can start. A gift package contains a set of 3 bars of soup. The mass in grams of each bar of soup is given by S, the normal distribution, and the packaging that the normal distribution. The gift package can be posted at cheap rate if the mass is under 250 gram. Assuming that S and T are independent, find the probability that a randomly chosen gift package can be posted at cheap rate. Okay. Now, in the package, we have three soup, three soup, and packaging or tea. So we can give a name to these. It is W. And for soup, nu or mean is 50, and variance or sigma square 4 square. And packaging, for the packaging, nu is 90 gram, and variance is 5 square. So we should find the nu and variance for W. Okay, now as you remember, the expected value of 3s plus t means the expected value of W, and it means 3 multiply the expected value s plus the expected value of t, and it means the 3 multiply 50 plus 90, so it means 240. For the variance, the variance value of W, it means the variance value of 3s plus t. Please remember that for the variance value, it becomes 3 square multiply the variance value of s plus the variance value of t. So 9 multiply 4 square, it means 16, plus 5 square, it means 25, and 169. 169, sigma square 169, it means 13 square. For the variance value, and in the normal distribution, the expected value of W, we could find 240, and the variance value of W 13 square. Okay, now in WAMP, we want to one package mass under the 250 gram, because if the mass is under 250 gram, the gift package can be posted at a cheap rate. So we want to find the probability of W less than 250. Firstly, please remember that in the normal distribution we should convert to z, and we used to value, and this formula is the probability of W minus nu over sigma, or standard deviation. And it means the probability of and 250 minus the expected value 240 over 13. So we should find the probability of W or Z, for example Z, less than 10 over 13, less than 10 over 13. I want to see a result of 10 over 30. 10 over 30 means yes, 10 over 30 means 0.779, 0.779. And if you remember that the normal distribution curve, this curve is here, and the middle of the point is 0, and 0.779 point here, and we want to find this area because we want to find z less than 0.779. So it's a big area, and when you look at the z table, and when you find the 0.779, you can see the big area value. So phi 0.779 means 0.77, excuse me, 0.769 means 0.779. Okay, now we have already been looking for the big area, so we can find the big area value by looking at the z table. Okay, now we will go on the linear combination, but now we will learn how regards to between linear combination and Poisson distribution. Firstly, I want you to remember that Poisson distribution's formula. In the Poisson distribution, the expected value and the variance value the same value, and it's called lambda. And the Poisson distribution formula and the probability of becomes R, means lambda to R multiply E2 minus lambda over R factorial. This formula we had used to in Poisson distribution subject. But now we will learn linear combination and Poisson distribution. What have they relationship? So the staff of a lion and tiger rescue center found they rescued on average 5 lions and 3 tigers per week. The number of lions and tigers rescued can be modeled by Poisson distribution. Okay, now for the lines is average 5 lines. This is Poisson distribution, and our average is 5 lines for the 5 lines. The Poisson distribution lambda is 5. And for the tiger, in the Poisson distribution, 3 tiger. Our average is 3 tigers. And in 1 week, only 2 animals were rescued. The possible combination, if we in 1 week we rescued 2 animals, it might be 2 lion, or 1 lion, 1 tiger, or 2 tigers. Okay, the possible combination, no lions and 2 tigers, or 1 lion and 1 tiger, or 2 lions and no tigers. Here is the calculation. Find the probability that 2 animals are rescued 1 week. For example, 0 lion and 2 tigers, or plus 1 lion, 1 tiger, or plus 2 lions, 0 tiger. And in the Poisson distribution, when we look at when we work out this process, we can find these results. But such as you see this process, it's very hard and it's very long. We can choose another process. For example, we rescued 2 animals. So tiger and lions. Tiger and lions, for the tiger and lions, 2 animals, for the 2 animals, we can give a name, for example A, and A in the Poisson distribution, we want to find expected value, or lambda. But in the for the tiger's expected value, expected value 3. For the lion's expected value 5. We rescued 2 animals, either tiger nor lion. So 3 plus 5, and the new Poisson distribution is 8. And we want to we rescued 2 animals, and we want to find the probability of 2 animals. So the probability of value 2 in the Poisson distribution, E 2 minus lambda multiply lambda 2 r 8 to r over r factorial 2 factorial. And when you look at the result, this result with before result the same. So the second process is very easy and very short according to before process. So in the Poisson distribution, we can use linear combination. For example, x value in the Poisson distribution, expected value lambda, y value in the Poisson distribution, the expected value nu. So in the if we want to find x plus y in the Poisson distribution, we should find lambda plus nu. Okay, and we have some example about Poisson distribution. Two brothers, Josh and Rowan, in touch with their parents by text. The numbers of text messages sent by Josh and Robin are independent. The number of text messages sent each week by Josh has Poisson distribution with mean 3.2. For Josh, Poisson in the Poisson distribution with mean 3.2. And then the number of text messages sent by Robin each week has Poisson distribution with mean 2.5. So Robin in the Poisson distribution with mean 2.5. And write down the distribution for t, where t is random variable defined the number of text message sent each week by Josh and Robin. So Josh and Robin define t. It means Josh plus Robin, and t in the Poisson distribution with mean 3.2 plus 2.5. So t in the Poisson distribution with mean means 5.7, and calculate the t greater than 5. T greater than 5, please remember that Poisson distribution is a discrete distribution, discrete possibility. So if we want to, the probability of t greater 5 means the probability of t6 plus the probability of t equals 7 plus infinity. And if you want to work out this process, you can use another process. So it means 1 minus the probability of t5, the probability of t4, and the probability of t3, and then the probability of t0. Okay, now in the Poisson distribution, 1 minus all probability have e2 lambda. Our lambda is 5.7, so e2 minus lambda brackets and lambda 2 r 5.7 to 5 over 5 factorial plus lambda 2 r over r factorial, lambda 2 r 3 over 3 factorial, and lambda 2 2 over 2 factorial, and then lambda to 0 over 0 factorial. Okay, now I want to look at the these process result, and it means okay, and now greater than 5, 1 minus 0 0.327, 1 minus 0.327, and it means 0.673. But they tell us this situation t greater than 5, it means 6 and 7 and etc. Okay, now in this example, the independent random variables x and y are given. X in the Poisson distribution with mean means 2.4, and y in the Poisson distribution 3.6. The random variable t, 2x minus y, work out the expectation and variance of t, explain why random variable t does not follow Poisson distribution. Okay, now x in the Poisson distribution 2.4, y in the Poisson distribution 3.6, and we want to expectation the expected value of 2x minus y, or the other name called the expected value of t, and it means, you know, 2 multiply the expected value of x minus the expected value of y, and 2 multiply 2.4 minus 3.6, so 4.8 minus 3.6 and 1.2. And for the variance of t means the variance of 2x minus y. So please remember that it is 2 square, the variance of x plus negative 1 square, the variance of y. So 4 multiply the variance of x. Please remember that in the Poisson distribution, variance value and the expected value is the same. For x 2.4, and the variance of y and the expected value of y the same in the Poisson distribution. So it means 4 multiply 2.4 plus 1 multiply 3.6, it means 9.6 plus 3.6, it means 13.2. Okay, now if you remember, if you notice that for t expected value we had worked out 1.2, for t the variance value we had worked out 13.2. But if for t Poisson becomes Poisson distribution, should be variance and expectation should be the same. So the expected value of t and the variance value of t are not the same. Uh, so t 2x minus y doesn't follow the Poisson distribution. This is not a Poisson distribution. Okay, so if you see the 2x minus y, 3x minus 2y, for example, and so 5x plus 2y doesn't follow Poisson distribution. Only 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 uh, x plus y follow Poisson distribution. X plus y follow Poisson distribution. Okay, only x plus y. Okay, for a random variable to follow a Poisson distribution, the mean and variance have to be equal. In this question, the random variable t does not follow a Poisson distribution because the mean and variance are not equal. Note that this example shows that when you find the mean and variance of multiplies of independent random Poisson variables, the resulting distribution does not follow a Poisson distribution. Okay? Now, we have two more example, and we will go on these example. The first example regards to normal distribution. The second example regards to Poisson distribution. For the first one,